Hey everybody, in this video we're going to show how to hook up an infrared remote to a CYD, Cheap Yellow Display, running LVGL. And in this example we're going to create a calculator and have the buttons from this Samsung remote go into the LVGL event handler so that a number 5 pushed on the keypad is exactly the same as a number 5 that is pushed on the touchscreen display. Similarly with the left and right buttons and enter and all those kind of things. So my name's John Broadwell. I'm an embedded systems consultant, medical device development consultant at my company, Broadwell Consulting Inc. I'm pretty good at this stuff. I'm easy to work with. If you need help with a project, give me a call. That's part of the reason why I do these videos, is to drum up some business. So let's take a look at the hardware that we're going to be using today. I'm using a resistive 320 by 240 CYD. It's the same one that has been popularized by the Random Nerd tutorials, so there's really good board setup and tutorials for this particular board. On the back, there is a connector, which we're feeding into this board. This is a custom design of mine that will be available as a Kickstarter later this year that adds 2 Serial Wombat I/O expansion chips and a bunch of quick connectors over the I2C connection that we're going to get from the CYD. Serial Wombat boards are a really good fit for CYD because despite all of its power, by the time they get done hooking up all the stuff that's on the board, there's usually only a handful of I/O left. So by adding smart I/O expanders to the system that can handle other embedded tasks as coprocessors, it becomes really powerful. And this particular board is capable of doing a lot, but in this case, we're just using it for its onboard pull-up resistors and the fact that it converts the JST 1.25 connector on the back of the CYD to DuPont pins that then we're breaking out to this board. So this guy, along with the CYD, is actually the star of the show. This is a Serial Wombat Remcon board that's capable of sending and receiving IR signals from remotes in either Samsung or NEC protocol. There's a receiver and a transmitter on this board, and there's also a Serial Wombat chip here running the Serial Wombat IR firmware that does I2C to IR protocol conversion. So the CYD doesn't actually have to decode the IR. The Serial Wombat board does the decoding and then transfers it as a stream over I2C. So let's take a look at this application, and I used ChatGPT extensively to generate this. I told it I wanted a 4x4 matrix keypad-based calculator, and I'll just throw up on the screen real quick the prompts that I used. Since I am a medical device developer, I feel obligated to tell you that I haven't validated this calculator, that it actually does math right. So it's a fun project, but don't use it to calculate radiation exposure times, to fire your retro rocket to land on Mars, for any important financial transactions, things like that, because as far as I know, occasionally you say 2 plus 2 and it may give you 5. Probably doesn't, but I haven't proven that it's not, and that's the difference between a medical device calculator and a normal calculator, is the validation. So let's take a look at the code. We generated this, and I'm not going to go real deep into this. This isn't an LVGL general tutorial, but let's look at the places where the Serial Wombat code touches the LVGL and how we managed to get these IR signals into the system. This tutorial is available on my GitHub under the YouTube stuff repository. There's a link to this down in the comments. There's also a link to the Serial Wombat Remcon board, as well as some other videos that show you generally how to use the Serial Wombat chips with LVGL, and a link that introduces this LVGL specific board that will be part of this year's Kickstarter. So we're going to use a PCB. It assumes you've installed the Serial Wombat library and all of the stuff you need to run LVGL. See my tutorials for Serial Wombat stuff and see the Random Nerds tutorial people for LVGL. We're going to have one board that's at address 0x60. It's a PCB 0041 Remcon board. That's my board. We've got a handful of setup stuff. I did another video you can see here, link to that down in the comments as well, that kind of looks at the template that I use. I use ChatGPT extensively with LVGL. ChatGPT does a great job generating code for things for which there are a lot of examples and a lot of good documentation, and LVGL certainly fits both of those. So the code generation is usually very, very good with very few errors. And so basically, I've set up a nice template that's designed specifically for the prompts that I use that allow you to dump the code in. So we're going to come in here. We're going to set up Serial just for debugging. We're going to set up wire begin. This is how you initialize the I2C bus. And every CYD seems to have a little bit different pinout. So for this one that we use for random nerd tutorials with the connector, the way I've got it set up, you're going to call begin with 22 and 27 for those pins. Once that happens, we're going to initialize the Remcon, and you don't really have to do much of anything with that board because it's the class that runs on top of the Serial Wombat class initializes everything that you'd potentially want to do with that, including the green blinking activity LED and everything else. Then we'll set up LVGL and just let us know, hey, we got to this point over Serial. And then we will call the ChatGPT generated calculator setup. Then once we get into the loop here, there's actually nothing that's application specific. All we're doing is calling the LVGL executive that was set up by this function right here. All of the CYD stuff, this is from the Santoses from Random Nerd Tutorials and is basically just pretty much a straight out use of that. So it is licensed under the same license that they use. So, and here is the net result of my ChatGPT and a little bit of customization, a lot of variables, a state machine that handles the calculator, format strings, all those kind of things. I'm not going to go into all that because this example is really about event handling from the Serial Wombat chip and not actually about calculators, but a calculator was a nice example. If we look through here, you'll find some functions. For simplicity, I originally had ChatGPT generate this as if it was a matrix keypad input, and then I just kind of overrode the output from its theoretical keypad with the input from the Serial Wombat IR remote control scheme. And so you can see in here, this is where it would be doing the keypad scan. In a future version of this example, we're actually going to also add in parallel with other Serial Wombat chips a physical keypad, and we will also add this little left, right, up, down, enter switch thing that will hook up to a Serial Wombat backpack board. And all of these will run together and all feed into the same event stream on this example. So it'll get more interesting. But in this case, we're just going to go and ask every time that it does a keypad scan, we're going to ask the IR remote over I2C, hey, read me the last received key. And if it's not -1 and some other stuff, if it's been a little while since the last time I got it, because with the keypad, with a remote, normally it does repeating. So like if you hold down the volume key, it'll continue to drive the volume of your television up. That's not really what you want for a calculator. You want each individual button push to be there. So there's a little bit of repeat and timeout stuff in here, and you can look at that code. I won't go into it in detail. But the interesting thing is you switch on which key was received. And so what comes in are different numbers that line up with the IR codes from the Samsung remote. So like on a Samsung remote, 0x0A as a command code is the number 6. And so what we're going to do is take each of these Samsung remote numbers and convert them into an ASCII character, and we hand that back to LVGL, and that's how it executes those particular things. So if we go and we look at ChatGPT EX keypad, that's in another function called ChatGPT EX keyboard read. You can see it goes here and it reads the keypad, and then this is where it sets up in that function a global variable that says this was the last key that was pressed, that then gets processed further down the line by the executive for LVGL. That function in turn is created as a callback that is set up into the LVGL that it uses to read the keypad. So, this whole stack is really something that's awesome to auto-generate. You need to kind of know how it works. And again, grab this example and you should be able to see it and integrate any keypad-based item you want into the same place where I'm reading the IR codes off of the Serial Wombat chip to inject those into the stream. So let's try it out real quick. We'll push a few buttons and see what happens. So here we go. Let's do 55 plus 5. 55 actually plus 6. And then I've got pre-check set up is equal 61. Hey, let's divide that. I may divide this button right here. Divide that by 4. 15.25. I have a clear button, which is this one. And one of the things that we did was we tied the arrows in. So you can see if I use the arrows, I can also navigate around. And so that would be really useful for something that isn't a calculator where you had a menu display system. So let's do 40. Times 3. And we'll go down to enter. And we get 120. So we can see that this is working really, really well, really solid. You can see over here, if you can see the green light blinking, the Serial Wombat chip is handling the IR input. And when it does, it also blinks that active LED so that the host is not actually driving that LED. We've configured the Serial Wombat chip to do that. So that's about all for today. Should be a good tutorial. If you have any questions, leave them down in the comments. Again, I'm not a super expert on LVGL, but I do know a lot about interfacing stuff and would be interested to hear. If you build a project based on this with LVGL, leave me a comment so I know what you're working on. Or if there's other interfacing examples that you'd like to see, leave me a comment on that as well. Until we talk again, have fun and keep making stuff.